Hi, good evening, Aslin.
Yeah, good evening. Can you hear me?
Yeah, you're audible. Am I audible to
Yeah,
you?
yeah,
Okay. So I pronounce your name like Aslin. What's your name?
Ashlyn.
All right. So how are you doing today?
Okay, yeah,
All right. Okay. So we are going for a demo session over your mathematics. Your father or your parent has shared your syllabus with me. So I'm just picking
yeah,
this topic, algebraic expression, and we'll be going together with this. Is that okay with you?
okay, yeah,
Okay. So first of all, we'll be going with some basic questions. Okay. Uh, Actually, I'm sharing my screen, so I may not be visible on the camera. This does not function, but you can turn on your
yeah, it's
camera
okay.
so we can have an interactive session.
Yeah,
Okay. So firstly, we begin with this, and then we'll be beginning with some questions in the beginning. I would like to know that are you comfortable just in English, or I should go in Hindi and English both? Because I can speak two
no,
languages.
English,
English, all
just
right.
English.
Okay. Okay. So here we begin. So where we are talking about algebraic expression, may I know from you what do you understand with this algebraic expression?
So algebraic expressions are expressions that have numerical and literal factors.
Right? Can you
Mm,
give an example?
yeah, 2xy plus
Yeah.
2xy plus z.
All right. Okay. 2xy plus z. Correct. This is an algebraic expression. So we are moving with the content from here. So here you can see like expression you talked about 2xy plus z. What happened? Yeah, you got
Sorry, my internet is a bit bagged. So
no problem. We can begin. And sure, my screen is visible to you or not?
yeah, it is.
Okay, wait a moment. Yes. So here we are. You just told me about algebraic expression, right? So we are coming with
Yeah.
some other terms. These are terms monomial, binomial, trinomial, polynomial, like terms, unlike terms, coefficient, and at the end, factors and identity. So if I ask about terms, do you understand what a term is in algebraic expression?
Yes.
Yeah, go ahead.
So terms are, for example, in 2xy plus z, 2xy is a term and plus z is also a term because the sign.
Right. Okay. So, do you know that with algebraic expression, not only the textbook, we can have real application in our life. Can you give me some example of real applications in life for algebraic expression?
I'm not sure as for real applications in life.
Okay. You may try, attempt anything.
Uh,
Okay, let me play a kind of
Not sure.
magical game with you. Uh, what if I
Okay,
uh, what if I tell you to think of a number in your mind right now? Just think of a number.
right now.
Okay, you have
Okay.
thought a number, and now just add five in that number.
Yes.
Okay, now multiply with four in that number.
Okay.
All right. Now you may subtract 20 out of that number.
Yeah.
Okay, now you may tell me what is the resultant number.
My resultant number was 80.
80. All right. So with algebraic expression, we can get that data. You thought of 15, right?
Yeah.
This is magic. You know how it came possible?
No.
Okay, I'm going to show you that magic. So that's how we can use these tricks to boggle the minds of our friends as well. Most often, you may have heard these kind of questions. These are nothing like magic, but these are mathematics. Okay, I'm going to show you this right now. So if I'm going to talk about in this way, so firstly, I would just ask you that I'm asking this question when I say think of a number. Let me assume it as x. Is that okay?
Yeah.
Okay. So you assumed a number as x. Now what I told you in second step, I told you that you must add what? Do you remember that?
Add 5 to it.
Hmm. So you must add, for example, 5. I'm just writing it in a Roman. So you added 5, all right? And what happened then? Then I told you,
Multiplied by 4.
yes. Then I told you through multiply by 4. Okay.
4.
So you just multiplied by 4, right? So what would be the result here?
4x.
Okay,
Wait.
wait. Yes. So it would be like 4x plus 20.
5.
Yes, this was 5, right? So it will be
Yeah.
20. Is that correct?
Yeah.
Now
Yes.
you just told me the result. That was what was your result?
80.
80. Now I needed to find what number you thought, right? So that is the value of x.
Yeah.
Is that true?
Yes.
And I hope you know that how to solve this, right?
Yeah.
Yeah, so 4x would be equal to 80 minus
Minus 20.
20. Yes. And then it would be like 4x is equal to 60, right?
Yeah.
Then we can divide this number by 4, right?
Yes.
So what will be the result? 15 fours are 60, right?
60.
Yeah, so the data is 15. The number you thought was 15. Did you like this magic?
It's interesting.
Yeah. So this is how we can construct many more stuff in mathematics using algebraic expression. Not only this, but sometimes you are told to calculate a data which you do not know, but there are some hints which are given to you in that process. So when you are given a hint over data, for example, I say there are 5 people and they need to uh, have a chocolate per each, and a chocolate costs 20 rupees. So in algebraic expression, how would we represent that data? That there are 5 people and they need chocolate. Just use your brain. There are 5 people and they need chocolate per each, one per each. Okay. There are 5 people
Okay.
and they need one chocolate, and a chocolate costs 20 rupees, right? So what will be the algebraic expression to show this data?
So,
I need to calculate the price of total chocolate, right? What I would do,
yeah.
we simply go with the assumption in algebraic expression. We will think about a variable, let's say x. So we will suppose the real price in such a way that may set this definition. As I told, there are how many people?
5.
5 people. 5 people are there. And what is the cost of one chocolate?
20 rupees.
20 rupees. So 20 rupees, and we know 20 rupees is the cost of one chocolate. So we may call it like X is the chocolate. So X costs 20 rupees per one, right? X is equal to
Yeah.
20 rupees. Is that true?
Yeah.
But when we have to find, when we have to find uh, for five people, then how many chocolates do we need?
5x.
5x. So 5x would be equal to what?
Mm,
5 into x was equal to what?
20.
20. So that's how we can
20.
go with this. So these are some real life examples which can be taken in algebraic expression. You know what usually happens with most of the students and teachers too? They teach the concepts mathematically through textbooks, but we forget to add it in our real life. That is most important stuff, that we must connect with all the stuffs what is coming in our syllabus, because math is not about just textbook, it is living mathematics in your daily life, right? So that's how we will be understanding the stuff. So we have taken two examples for real life. Now we will be going with this material what we are having on the screen. Now you will enjoy it. Okay, so you already told me about the definition for expression, but let's see what it is coming. Like you told me that definition was correct because expression are formed by using variables and constants. You told in your language, that is okay. So now there are coming two terms. One is variable and second is constant. I hope you understand variable and constant well, right?
Yeah.
Like we have used this in our real example. So x plus 3, what is the variable and what is the constant here?
The variable is x and 3 is the constant.
Okay. What about this? Like 3x square. 3 is what?
The constant
Okay. And x.
variable.
Okay. And this square, this is power 2. What will we call it in expressions, algebraic expressions?
Will it also be called constant?
Constant. Any other name or term is given to this in algebraic expression?
I mean, it can be called a power.
Yeah, we can call power. Anything else?
Mm, I'm not sure
Okay.
what else.
Okay, I'm giving you a hint. D4.
Mm,
Okay. This is degree. In algebraic expression, as per your syllabus, there is a term. You need to find the degree of algebraic expression. So when we are talking
yeah.
about degree, right? So the largest value having as exponent or power is called degree of the algebraic expression. So here is the degree for this algebraic expression is 2, right?
Mm.
Can you tell me the degree for the first example, x plus 3?
So degree 1.
Great, great. Yeah, you've told correctly in this way. So here we are having these expressions. If we take the example of 2y minus 5, it is made up of y as the variable, as you already understand, and 2 minus 5. These are constants. These can be negative and positive too, right? Okay, so now coming to the part of terms, you already explained this earlier. Terms are added to form expressions, like there are the terms in we can see 5ab plus 90. How many terms are there? Can you see?
There are two terms.
All right. Yes, so terms are commonly made up of coefficients, variable, and constants. Do you understand what is coefficients? What is
Mm,
coefficient?
Coefficient, any one of the other factors in a term is called a coefficient.
All factors in a term is called
No,
coefficient.
any one factor in a term is called coefficient.
Okay, so in this term, what is the coefficient?
So the numerical coefficient is 5 and the literal coefficient is a and b.
You have to understand that we have to categorize it into numerical or literal, because this is
Yeah.
something very important. In algebraic expression, when we are asked for coefficients, we do not give literal data, but we give numeral data, right? Coefficient is a constant value which is uh, placed before a variable. So here we can see the coefficient for this AB, the coefficient of this variable A, or A and B multiplied together. 5 is the coefficient value in this 14, and in this m cube we are having 56. So we must understand what coefficient actually stands for. So it is a constant data just placed before a variable. Do you understand?
Yeah.
Great. Okay, so here we are having some terms like uh, these terms we have understood now: monomial, binomial, trinomial. This is also part of your syllabus. So do you know what is monomial?
Monomial is an algebraic expression with only one term.
Great. Example:
Um, 8xy.
8xy. Okay. All right. 4. This is monomial. 4, only 4.
Only for that's not an algebraic expression
Okay. How can you justify that that is not algebraic expression?
because algebraic expressions are formed by a combination of constants and variables.
Okay. So what if I say I have written 4 here and I'm writing x to the power 0? Do you know power of any number when it is 0, what is the value?
One,
Yes. So I can say 4 into 1 is equal to 4. So here I
yeah.
have used x to the power 0. The degree is simply 0. So how come it can't be an algebraic expression? We have to understand this.
Mm,
Do you understand? Like any number,
yeah.
even that is constant only, that may also come as algebraic expression. So this notion should be broken out. Like if any number is not having variable, then it is not algebraic expression. No, this is incorrect. So we have to understand like any algebraic expression can be in the form of constant too, right? Like here you can see this example -11. Your mind may think in the way like, okay, it is not having any variable, so let us not call it algebraic expression, but that is assumption, right? What most of the students have. So you may lose the marks in exam. So I hope you understand why -11 is algebraic expression, because we can assume a data of variable like x, y, z, and but we will give the exponent value that is 0, right?
Okay.
Yes. So you may take a screenshot of this because your definition was correct. Just a little thing. An expression comprising of only one term is known as monomial. That was correct. But when we are talking about one term, that term can be variable or constant, both. Why?
Okay.
I'm aware of the fact that term may have the variable having 0 degree, and when it is having 0 degree, that may not be written, right? So that is the reason. I hope you understand, right?
Yeah.
Okay, now binomial, of course this is easy to guess because mono means one and bi means
Two.
two. Okay, so what would be the definition you may construct in your language?
An algebraic expression, if there are two terms, is
Yeah,
called binomial.
great. Such an intelligent answer. Great. And trinomial, of course you can get that. How many terms in total?
Three terms.
Great. Very good. Now there comes a term which we call polynomial. Do you understand what is a polynomial?
Polynomial is when the algebraic expression has more than one term.
Yeah. So polynomial, monomial is can't be count as polynomial.
No, monomial can be counted as polynomial. One
Monomial,
or more term.
yeah, one or more term. It means everything like monomial, binomial, trinomial, these all are counted as polynomial. But yes, poly means many. So basically, the root definition was given to it so that it can contain many data, but it also contains monomial and trinomial and all, right? So in general, an expression containing one or more terms, as you told, but here an important stuff we have to remember, that is non-zero coefficient. Why non-zero coefficient we are having here? Do you know?
No.
Okay, so let me make you understand. If I am writing here something like 0, okay, I'm writing here 0, and then I'm writing x, turn on the camera, and I'm writing 1. Okay, so 0x plus 1. So can you tell me this is monomial, binomial, trinomial, or what?
This binomial.
Yeah, you are confused actually. That's why we have this definition. 0x, 0 multiplied with x, 0 multiplied with any number would be equal to
Zero.
0. So initially, what will you call it? It would be equal to what? 0 plus 1, right? Isn't it?
One.
Yes, so it will be equal to 1. Now you see clearly how many terms are there?
Only one.
1. That is the reason the definition is containing non-zero coefficient. Because 0, if 0 is the coefficient, the value will be 0 for that variable too, right?
Yeah.
For example, 0x square plus x plus 1. Can you tell me what polynomial is it? 0x square plus x plus 1.
Binomial.
Great. Nice. Clapping. So you've done well in this term. So we have understood, like, non-zero coefficient is necessary in polynomial because if we are putting 0 as a coefficient, the value for that variable will be 0 and would not be counted, right? That term would not be counted. Great. So this a plus b plus c plus d, how many terms are there?
Four.
For so what is this? What would we call it?
Polynomial.
Polynomial. Yes. Uh, would they fall under binomial, monomial, trinomial?
No.
No. Great. Okay, so you've understood this very well. Now we are moving with next part, like terms and unlike terms. If I ask you what is like term, can you explain?
Like terms. Like terms are terms with the same literal coefficients.
Examples?
Uh, for example, 8xy and 32xy.
Correct, correct. Better you may call it variable. You are using it in your
Okay.
language literal, that's okay to understand basically, but we will call it variable. So next time when you define it, give the proper definition, right? So of course you are saying it well. Any expression which is having same variables, like you said, same literal terms, that's okay to understand, but we will sophistically call it variable, right? So like terms are formed, you can take a screenshot, from the same variables. The power of these variables have to be same to be a like term, right? And coefficient of these like terms may or may not be the same, correct? Because I can say 7xy and 8xy. Here, coefficient value is 7 and there 8. There is no problem at all. But variable data should be same, correct? So here we can see 7xy and 8xy. This can be uh, mm, taken in mathematical operations, right? So if I say
Hmm.
um, add both of them, what will be the value?
Mm, be 15xy.
15xy. And second one?
What is that? Okay, 12x square.
Great. And this one, last one?
7xyz.
Great, great. You've understood this. So these are like terms. So opposite to this, there comes another term. Can you guess that? What is that? Opposite of like terms.
Unlike terms.
Great. So
Unlike terms.
what would be the definition for that?
Terms with no common variables.
Yeah. Terms which are having different variables can be termed as unlike terms. Great. So terms that do not have the same variable content are said to be unlike terms. You can take a screenshot of that too. In unlike terms, the powers of the coefficient of the variable may or may not be same, like 7k square and 11g. Can you add, multiply, or subtract them? Is it possible?
No, it's
No,
not.
not. But we can write them with those mathematical operations symbols, right? Like 7k square plus 11g, right? That is possible, right?
Yes.
Great. So I hope you understood this. Now we are coming to this part, coefficient, as I already introduced this to you, and you also tried to define it. The numerical factor of a term. Now you see, like numerical factor. You may take this definitions screenshot because here you were confused a little bit. So
Yeah.
this is very important thing, numerical, right? Or we can call it constant value, right? So numerical factor of a term is called its numerical coefficient or simply coefficient, right? So this is not like you were saying earlier, like literal coefficient or numerical coefficient. In algebraic expression, there is only one coefficient value possible, that is constant. Okay, I hope you understand this. So we will call it
Yeah.
numerical coefficient or simply a coefficient. There's nothing to be existing literal coefficient. Okay, that may be our assumptions, but this is what comes as coefficient. So here 7xy, we see like what is the coefficient value, the numerical data, that is 7, and variable
XY.
7xy. Okay, so this is what we have understood so far. Now coming to the part of factors. Yes, here is what you can judge in both of the ways, literal terms and numerical terms. So the terms themselves can be formed as the product of factors. For example, 14x. So it is having 14 as first factor and second factor x. Okay, so this is not having that differentiation, like you will be only extracting numerical data and you will not be extracting literal data, that is variable. So here you can say that earlier example you were giving for a coefficient. So here you can give that example. I guess you were confusing between both, right? So now can you define factors in your own language?
Uh, Factors.
Okay, let me help you. Factors can be product or multiplication of different terms, either that is variable or constant, either that is literal or numerical.
Okay.
Okay, so you may define in your way now.
So factors are terms that can be written as a product of one or more numbers and variables, and
Great,
that can be literal factors or numerical factors.
great, well done, well done, I'm happy. So now coming to this part, addition of algebraic expression. So you have already understood like algebraic expressions and unlike algebraic expressions. So any mathematical operation would be done on the like algebraic expression. In case of unlike algebraic expression, we will not be able to perform operations, but we can write. So here we see 7x y 5yz and 3zx. Okay, and in another parenthesis, we see like 4yz, 9zx, 4y, 2xy, 3zx, and 5x. So there are we are having them in positive or negative term. So can you find what would be the value for this? Can you simplify it? Is it possible for you now? 7xy. What is
I mean, there
the?
are
Yes, yeah,
common uh, 7xy and then negative 2xy.
yeah, yeah. So what will be the answer for this basically?
Uh, 5.
Yes, 5xy. Okay. Then next part.
Then 5yz, and then there's plus 4yz.
For yz.
So 9,
Minus
9yz.
positive or negative.
Positive.
Okay. Then next.
Then there's 3zx, and
Yeah.
then 9zx,
Yeah.
and 3zx.
Yeah.
Um, so is that also going to be plus? Mm, so 3zx.
Yeah. 2 times 3zx in negative and 1 time
Yeah.
9zx in positive. How do you see them?
You When you add the 9zx to the minus 6zx,
Hmm.
it becomes 3zx.
Yes. So it will be 3zx, correct? And now
Yeah,
we are coming to the part, the data which is remained, that is positive 5x, right?
yeah,
Okay. So we are having
and
this
minus 4y.
and minus 4y. Great. Great. So this basic understanding you already have. Great. So we have understood so far the definitions and how we can do mathematical operations. Like one of the operation we have done, that is addition. We can also do multiplication. We can do subtraction, division, and all, right? Which can be possible. Correct.
Yeah.
So this is what we have done here so far. Let's move ahead. The methods can be different. um, like you've done it simply like in general term, but here when it is coming uh, about methods, we can use some methods. Do you know some of the methods?
No.
You directly do it, right? But in your
Yeah.
book, if you see the exemplar, there are methods given. Okay, so that we may also go through, but we know like we usually do it in general term, um, based based on our logical understanding. So write the terms of first of terms of the first bracket in this way, and then followed by this. So these things you can do. You can take a screenshot because that is related to basic understanding because you're able to solve it, so there is no need to tell about methods. But when it is about to be expressed, you can express in this way. This is how you explain to others, right? So we have written this term, these terms like this, and second this, and then this, and we have then done mathematical operation. And this is method two, which is generally taken by the students. All are written in this way, and then we are opening the bracket. The data which is negative is written negative, and then we solve the problem. You can take a screenshot of this too. And when we are talking about going to another method, so we can go with different approaches which we are having in our mind. Now subtraction can also be possible in this way. Just you need to understand, like in this method, I was showing you this opening the bracket. So here this becomes very important for us. So can you tell me what would be the simplified form of this data algebraic expression?
Mm, 12a minus 4a.
Hmm.
So what? 8a?
Okay. Then
9ab minus 7ab. So 2ab.
no, that's incorrect. Think about the logic. Okay, let me give you a hint by showing this. Um, this is something like opening the bracket, right? So this is the hint for you.
Yeah.
Now you see like this minus symbol here. When we'll open the
Yeah.
bracket, what would happen?
Becomes plus.
Yes, you got it. Now you can go with the calculation. So it will become plus 7ab. Now what would be the result?
Minus 2ab.
Yeah, minus 2ab. Correct. Now next.
Then that plus 3b becomes minus 3b, right?
Very good, very good. You've done well. So now what will be the result?
Mm, 2b.
Positive, right? Positive 2b.
Yeah.
Yeah. Then this
And
is very
then
simple.
the divided by 3. So
How much?
mm, minus 9.
No. Why minus 9? Positive 9. Because the
Oh,
small number is
yeah.
in negative. So this will be the data. Okay. I hope you understood
Okay.
this. So these operations can be performed either subtraction, multiplication, addition, division. Okay. So this is what we have to understand. So methods are already told to you, and multiplication can also be done, multiplying in this way. So first, this is very simple data. You may multiply the numerical data like 3, 15, and 2. This is easy, right? You can do this, right?
Yeah.
Okay. Now, what about this? You can perform these type of calculations?
No.
No. Okay. We are having just 2 minutes to here to solve this question. So I'm just telling you in just shorter way. Like firstly, we need to treat this data with this. So what we'll be doing, we'll be just going with this first, right? 2 minus 2x. So this we are multiplying together. So minus 2x we have taken outside. And then we are going with this data, positive 2. We have taken this outside with along with this x plus 3. Same you can do from this side, like x can be taken out and multiplied in this, right? So we have taken
Yeah.
this. Now we can multiply 2 and 2 will be written, minus 2 will be written, and x into x is equal to x into x.
2x.
No, x into x is equal to
Yeah, x
not
squared.
x
X
square,
squared.
correct. So here it is x square, and then 2 into 3. So it will be uh, positive 3 and my negative 2. So it will be negative 6, right?
6. Yeah.
So negative 6 and then x and then plus, and then we are having the same here. 2 into x is equal to 2 into x,
2x.
2x, and positive 2 and 3 both are multiplied, then positive
With 2.
into 3. This we can see
Yeah.
2 into 3.
Positive 6.
Yes, correct. So here we are having complete data, minus 2x square minus 6x. So like terms are here, minus 6x plus 2x. So we will, the first minus 6, this is the larger number and in negative. So it will be negative 4, right?
Yeah.
Minus 6. So 2x square minus 2x square minus 4x plus 6. That will be the right answer. So likewise we can do.
Okay.
So till here we have covered, and we will be understanding the stuff in next classes. I hope you enjoyed, right?
Yeah.
Even Vedic mathematics can be worked in the same way. Have you heard about Vedic mathematics?
Yeah, I've gone for a few classes for it.
Okay, so we will do that as well through algebraic expression. So thank you very much for taking this session.
Thank you.
Bye. Take care.